Welcome back to part 2 of Module 6, Lesson 6, Inequalities. We're going to pick up on example 2, graph inequalities, where they give us a problem that says x is less than a negative 5 75/100. And the first question they have is, what does that symbol right there mean? Well, that means that the value of x is going to be something smaller than 5 75/100. It's also just less than, not a less than or equal to, and that means that it cannot be equal to 5 or 75/100 either. It can only be a value less than it. So from there we're going to take that and we're going to graph it. Because it is not an or equal to, that means we are going to have to take and use an open circle on the number line. And let's see here. Now it's ready. The symbol indicates that that the negative 5.75 is not going to be included in the solution because it's not an or equal to. So we're going to check that, move on to the next part, and then we want to use a open circle because it is not an or equal to, and we're going to check that, and then the solutions are going to be any value that is less than negative 5 75/100. Check that. Easy math. From there, that means the arrow is going to point what direction goes less than negative 5 75/100. That's going to be to the left, and it includes the numbers that are less than negative 5 75/100. That's all that. Now what happens if we actually want to graph it? Well, to graph it, we're going to need to find an open circle, which is going to be right there, and that open circle is going to go right here on the negative 5 75/100. And let me figure out how to actually put that there because it doesn't seem to want to go. Hold on. Well, to help to read the instructions, we're going to grab the open circle. We're going to click on the negative 5 75/100, and we're going to drag it all the way to the left-hand side there. And now you can see that that has ended up being highlighted. So that will be our answer. We're going to hit the check button, and our answer is correct. Easy math. And now it's going to be your turn to do one with extra example 2, where you're going to graph the inequality x is greater than 2 25/100. Pause the video and do this, please. Alright, so we have not or equal to. It says x is greater than it, but it is not or equal to it. And since it's not or equal to it, that means that I'm going to have something that is an open circle. So I'm going to choose that one. It's bigger than it, so it's going to go to the right. And what's it going to go to the right of? It's going to go to the right of 2 25/100. So I'm going to click on that. I'm going to start at the 2 25/100, and I'm going to go to the right. And you can see that is all highlighted. I'm going to check my answer, and the answer checks correct. Easy math, nothing to do on these problems. But what if you had one like this that was an or equal to? This one says that x is greater than or equal to 2/5. Because it's or equal to, that means we're going to have to use the closed circle on it. So going through their questions here, we're going to take, actually no questions at all. Because it's an or equal to, we're going to use a closed circle at negative 2/5. Negative 2/5 is negative, no, positive 2/5. Positive 2/5 is right there, and x is going to be greater than a positive 2/5 or equal to it, so we're going to use a closed circle on positive 2/5, draw our arrow to the right, and let go. Check our answer. The answer checks correct. Easy math. Alright, your turn. You guys go ahead and move on to the next problem and work it on your own. And that next problem is going to be x is less than or equal to a negative 1.2. Go ahead and stop the video and work on that one on your own. Now looking at the problem, let's zoom in for a minute here. Whoa, not quite that much. Our x value is going to be less than or equal to a negative 1.2. The or equal to says I have to use a closed circle. The fact that x is less than or smaller than the negative 1.2 means I have to go to the left of it. So coming down here on my number line, I'm going to grab the closed circle, And at negative 1.2, I'm going to click and I'm going to drag, and there's my graph of it. If I was to check it, go up here, check, it checks correct because I did the correct thing. Easy math. When you replace a variable with a value that results in a true sentence, you solve the inequality. The value for the variable is a solution of the inequality. Some inequalities have infinitely many solutions. For example, any rational number greater than 4 will make the inequality x is greater than 4. And we're going to take and select each whole number value to see if it's going to be a solution of this one right here, which says 2 plus x is equal to y. So if I was to take and select the 5, 2 plus 5 is 7. 7 is not going to be greater than 9. If I was to select the 6, 2 plus 6 is 8. 8 is not going to be greater than 9. How about 7? If I clicked at 7, 2 plus 7 is 9, and while 9 does equal 9, it's still not greater than 9, and this is not an or equal to statement, so it can't work. But when we get to 8, now we have 2 plus 8 is 10. 10 is greater than 9, making 10 a valid answer, just like, 8 a valid answer, just like 9. 9 plus 2 is 11, making 9 a valid answer as well. From that point, we could keep going to 10, 11, 12, and so on, and any other numbers higher than the 8 is going to give you a solution that is greater than or equal to 9 for that inequality. Now the textbook wants us to do example number 4, which says a plus 4 is less than or equal to 11. And in this one, they give us options to choose from. We can try 6, we can try 7, and we can try 8. And they want us to plug each of these values in to solve that inequality or to find the true solutions to that inequality. So let's start off with looking at the problem. And it says that given values are 6 and 7. There was also a given value of 8, but hold on just a second while it catches up. All right, we're good here. So where they plugged 6 in for 4, that gave you 10. 10 is a value that is less than or equal to 11, so that is going to be true. That is a true solution to the inequality. Well, how about the 7? 7 plus 4 is 11. 11 is less than or equal to, it's equal to 11, so that is also going to be a true solution. And then when number 8 plugs in there, 8 plus 4 is 12. Is 12 a solution of the inequality? It is not, because 12 is actually going to be greater than 11, so that's going to be no. We're going to click check our answers. All is going to be good. So the only two numbers that would work are going to be either 6 or 7. 6 and 7 are valid solutions to the inequality. 8 is not. Now it's going to be your turn to work another problem. Go ahead and pause the video and check the values 6, 7, 8, 9, and 10 and find out which ones are going to be valid solutions for D minus 6 is greater than or equal to 2. So did you get the right answers? Let's check them out. If I put 6 in for D, 6 minus 6 is 0. Is 0 greater than or equal to 2? It's not. 7. 7 minus 6 is 1. That's still less than 2. How about 8? 8 minus 6 is 2. Is 2 greater than or equal to 2? It is indeed going to be equal to 2. And then for 9, 9 minus 6 is 3. 3 is going to be greater than 2, so that'll work. And then 10, 10 minus 6 is 4. 4 is also going to be greater than 2, so that'll work. So your valid solutions are going to be 8, 9, and 10. We're going to stop this video right here, and you're going to come back to watch part 3 of this lesson as we continue on our study of inequalities.